Right, Ronny, I'm going to say this wrong. Andrade? Terrible, isn't it? Accessibility in video games. Thank you very much.
Sorry, just use this one. Hit that to forward. Oh, you go right inside here.
All right, ready. Yep, good afternoon, everyone. My name is Ronny. I'm also doing a PhD, and I'm looking, video games and accessibility. I'm focusing on accessibility for people with visual impairment and video games. I'll share with you what I've been doing on the first 6 months of my PhD. First, I'll talk about the problem. Amanda actually made an awesome summary of this. She highlighted the trends on the game community, and we can see that gaming is a growing industry. But at the same time, the gaming industry is, games remain inaccessible. And why is that? Basically because video games require from players a set of sensory skills that sometimes they don't have. This is particularly true for the case of people with visual impairment, because as we know, the main output for a video game is video, is graphics, right? And so even though 1 billion people have tried a virtual reality, this is particularly a field that remains mostly inaccessible. Why is this important? In my opinion, this is important on 2 different fronts. One of them, it's because vision-specific distress was the strongest predictor of depressive symptoms in people with vision impairment. So there's a correlation between sight loss and depression symptoms. And also because, as Amanda said on her talk, there is this potential for technology to create engaging experiences, to take us to different worlds. And so it's worth trying to see if there's a connection between these, if we can reconcile these 2 points. So I'll talk about how others have approached accessibility in video games for people with visual impairment now. First of all, I have found 3 approaches that people have followed. The first is supporting existing accessibility tools. That means providing access on your game to screen reading software. Also creating dedicated virtual environments. And finally, providing tools for improving accessibility in existing games. The first case, it's basically supporting screen reading software. Creating virtual environments, it's more specifically used for orientation purposes. So a virtual environment is designed and it models a physical world location, and the person with vision impairment is asked to navigate the virtual environment before they go into the physical environment. And there has been correlation found between successful navigation of the virtual environment and successful navigation of the physical environment. And now I have a little example of how on a mobile game, access to screen reading software is provided. You'll hear to it.
Crafting Kingdom, main menu. Play, button. Double tap to select. Tutorial, welcome.
So what you could hear is a game called Crafting Kingdom, in which basically you use the accessibility features embedded in Android in this case to navigate through the different elements of the game. Now there's a new trend, by the way, on accessibility on games for people with visual impairment. These are audio games. So audio games are computer games that feature complete auditory experiences that can be played without any graphical user interface. Examples of these, maybe some people in the audience are familiar with Papa Sangre or Castaways, Shadows of Doom. Maybe those names are familiar for some people here. There's this website, audiogames.net, which has a collection of around 700 audio games. And the genres of the games, there's everything. There's everything you can imagine. There's action, there's fighting, racing games, puzzle games, And all of these games don't require a visual interface for you to interact with them. And how do people who play these games understand them? Well, there's two key concepts here. One of them is the concept of an earcon, and the other is the concept of an auditory icon. Now we're going to listen to an earcon, and I think it'll become very clear for you what it is. This is an example of an earcon that's very popular. So an earcon is basically a specially created musical tone that conveys a message. What was the message of the earcon that I just showed you? Phone call, right? Exactly, my phone ringing, very good. Now let's see what's an auditory icon. That was footsteps, right? So auditory icons are sounds that are modeled after sounds in the physical world, in our real environment. And with the combination of these tools, it's how people interact with audio games. Other ways to interact with audio games, mostly to interact actively with them, to react to audio games, is with verbal instructions, so using voice commands, with time-based mechanisms. This is basically you have an earcon that's going to tick after a certain amount of time, and then you know that you have to perform an action. And finally, on a grid-like navigation mechanism. Like the name says, you are in a grid, you're a player in the middle of a grid, and you move around the grid in four directions, north, south, east, west, and all the places where you can go are fixed. Now I'll just have you listen to a short demo of an audio game called Castaways, and you will hear how the grid system works.
D11, rocket terrain. D12, stony field. D13, land. D14, land. F14, water.
So you could hear, right? It's like navigating Excel. E13, E14, similar to Excel, but it tells me what's the element on that cell, and it gives me a little auditory icon, right? Oh, I'm walking on rocky terrain, or I'm walking on water, and you can hear the actual sound of the element. Now, what have I done? I was thinking about this. How can we approach this? How can we make this more interesting? And what I think is the grid-based approach is limited in the sense that virtual environments are created to evoke an explorative experience. The idea of virtual environments is to have an open-ended experience where the player is free to roam around wherever they want. And the grid-based approach is very limited in that you can only go in 4 directions. So I thought, how can I make 3D environments more accessible? And I read a lot, and I found about echolocation, which some of you might be familiar with. So it consists on producing a click with your mouth, and then listening to it bounce back over your surrounding areas, over your surroundings. And that gives you a mental picture of your surrounding environment. Echolocation has a neurological basis as the visual cortex of people who has lost their sight gets repurposed for processing audio. The physical features of echolocation have been modeled quite in a very detailed manner. So we have found their length. So an echolocation click lasts from 3 to 10 milliseconds. There's an interval of space between each click. Also, the sound level in decibels has been captured, and the frequency of the sound wave has also been captured. So with all this information, it's been easy to produce artificial clicks that could be used potentially for echolocation. And that's what I did. I just ran some MATLAB code and generated these artificial clicks and tested them. To test how echolocation would work on a virtual environment, I've been doing some user studies at the University of Melbourne. So far, I've only had 4 participants, and what I did is, out of the 4 participants, 2 have low vision and 2 were blind. And what I did is I put them to test 3 different rooms. And in each room, there was a goal where they had to reach. And I wanted to see if using this artificial click and listening to the echo, which I could model on this 3D virtual environment, would help them find the goal. On the screen, I'm showing the 3 rooms that people had to go through. One was a long corridor. The second one was modeled after a bedroom. The third one was a living room with a U-shaped wall in the middle. And what I found, actually, there's a very short clip of one of my users when he was running over going over the virtual environment. And I'd just like you to listen to some of the quotes that he made while he was playing.
So normally as I move closer to a wall, I hear it more clearly than I'm hearing it here.
Okay.
It's interesting, there's a bit of background noise too beyond the headphones, and that has an impact. But now it sounds like I should be fairly close to the left wall.
That's great.
Yeah, yeah. My ears will now have to be very close to the cat. It's left and right. I can't tell how far it is in front or behind me, of course.
So he points out that he can perceive a wall to his left, and that's quite accurate. He said that when he was actually next to a wall on his left. He talks about a cat. The goal for this level that he was completing was to find a cat in a room, and so he could tell that it was clear for him whether the cat was on the left or on the right, but he couldn't tell if the cat was in front or behind. And so the preliminary results that I have found with my 4 participants is that all of them could complete the different levels, albeit with some help. Orientation cues could be used to improve interaction. One recurrent comment is that it is very easy for them to get disoriented because they have freedom of movement. They can move 360 degrees in any direction. So they said, I need to find a way to know which way I'm facing. Otherwise, I just get lost very easily. Something that I find very interesting is that the level of detail that each participant could perceive from the echo is different. I found that my 2 low vision participants, they couldn't really get more, like a big advantage out of the echo, whereas the 2 blind participants could get more advantage out of it. And even between them, one could perceive things in more detail than the other. And finally, training might be required. Something that even on the previous clip was mentioned is that the artificial click sounds different from the click they produce in the physical world. So they need to get used to this new virtual click and learn how it sounds when they are close to different surfaces and different distances. So from here, what I need to do now, what I'm trying to do now, is first getting more participants, wink, wink, and see if see if I can make some actually relevant and probably generalizable conclusions. I really want to see if more people actually can use these, or the 2 participants that could use this was just like not the norm, not what's common. I want to see if this is generalizable, if more people can actually use it. But for that I need to test with more people. And then, to be honest, I don't know. I'm just 6 months into my PhD, and I know this stage very well, but what the future for this research will look like, I'm still not sure. So I'm open to comments on that. And the take-home message, the one thing that I would like you to remember from my presentation is something that has been said before by a few people during the last 3 days. It's about the curb cut effect. So it's when we build for accessibility, we end up improving everyone's lives. So if this echolocation approach works and is usable for people with visual impairment, maybe I'll end up introducing a new way for people to play and enjoy video games. Who knows? That's it. Thank you.
I'm just wondering, I believe Google have been doing work on this question too, and there have been questions about your differentiation between two kinds of sounds using the audio icons to represent it. So are you aware of work that Google's doing? Because maybe they should be aware of what you're doing.
Actually, Microsoft is doing something similar. The Soundscapes projects that David mentioned in the morning, it's somewhat similar. It's exploring, but they focus more on physical environments. I'm aware of Microsoft doing something similar.
Hi, thank you very much. That was a really exciting talk. I was wondering if your test users, did they have any experience with echolocation? And it might be interesting to see the difference between users that have and users that haven't.
Yeah, thank you. Yeah, I've been lucky enough that the 2 blind participants that I have had can use echolocation in the physical environment. Yep.
One question: do you need an agent if you're going to go to Google? Because 20%, and I'll do all the deal for you.
I'd appreciate that.
Are we on? Hello? Yep, great.
Why don't you go first? Andrew.
Because the mic's not working. Oh, there we go. Many decades ago, I wrote an honours thesis which included quite a lot of discussion about echolocation. I'd like to talk to you over afternoon tea about that.
Yeah, sure.
And I'll show you my mini guide at the same time. No percentage.
Yeah.
And I have a video at home that you might find useful as well. Thanks.
Awesome. Thank you to you.
A couple of comments. The first one is I'm sure that there will be, when it comes to recruiting participants for this, I don't think that you'll have any trouble. I don't know, whereabouts in Sydney are you based?
No, I'm based in Melbourne.
Okay, so I would have a chat with some of the organisations that represent the needs of people who are blind or who have low vision. I don't think you'll have any problems.
Thank you.
The second thing is, a couple of months ago, I participated in a Catalyst program on the ABC where they freaked the hell out of me. It was virtual reality, and they set me up in this lift and had me walk out on a plank, and it scared the crap out of me. But I wonder about the similarities there as well, where we're talking VR. I was wearing a headset. Yes, I could see the virtual environment, but the entire environment was virtual, and the sounds would change according to me and my position. If I looked to the left, I would hear particular sounds. When I went up in the lift, I heard the sounds of the lift.
Yes.
So it was all, I wonder at the similarities.
Yeah, I didn't go into much detail on the actual design of the virtual environment, but I designed it with Unity. And so, because it's designed with Unity, it's at the moment works on a desktop computer, but it's very easy to adapt it and to make it work on a virtual reality headset. And yeah, I'm using 3D binaural sound, which basically lets you know if a sound is coming from the left or from the right, and even play around with the loudness of the sound based on the distance. Yeah, there are huge overlaps between what I've been doing and what can be done for virtual reality.
I mean, you're really talking about augmented reality, where someone else mentioned Google Glass, but that type of thing where you're using technology to survey the landscape around you and to see what's there. I mean, I can actually really imagine someone having, as your technology develops, being able to go into an environment and wave their virtual gun around and know where the baddies are and know where the goodies are and hear all that as they scan around the room.
Yes, that augmented reality could be very interesting and could be done. I think it could be done, yeah. So maybe have a model built beforehand like others have done and then blend it in at the same time that the person explores the environment. So unlike previous research where the blind person has been put in the virtual environment before going to the physical environment, the two things could happen at the same time, and yeah, it could be an augmented reality application. You're right.
Okay, we're going for a break,
Thank you.
and we'll come back at 3:30.